Hello everyone. Last time we covered the Einstein STR, and in that we studied about the relative speed in different frames, different objects, right? In today's lecture, we're gonna move forward with some more questions in the relative speed. Okay, so last time we did up to here. Next question: a spaceship moves away from Earth with a relativistic speed v and fires a shuttlecraft in forward direction. At a speed v relative to the spaceship, pilot of the shuttle launches a probe in forward direction at a speed v, speed of the probe relative to the Earth. Bullets forward. ओके तो एक स्पेसशिप है जो कि अर्थ से वी स्पीड से मूव कर रहा है दूर की तरफ, और एक शटल वो क्राफ्ट वो मतलब फायर करता है अपनी उसी डायरेक्शन में जिस डायरेक्शन में मूव कर रहा है एट स्पीड वी रिलेटेड टू द स्पेसशिप. ओके, pilot of the shuttle launches a probe in the forward direction at speed v. अब शटल के अंदर से भी एक हमारा प्रोब निकलेगा, लॉन्च होगा, वो फॉरवर्ड डायरेक्शन में होगा v स्पीड से. स्पीड ऑफ प्रोब बतानी है रिलेटेड टू द अर्थ. ओके, सो लेट्स सी. वी आर with respect to a is given v, that is the shuttlecraft. Okay, we are denoting it with r. Rocket is moving forward with respect to earth in v, speed v, and fires a shuttlecraft. Now shuttle is showing by s. Shuttle with respect to r given is v in the same direction. Now next is a probe is launched from the shuttle, that is velocity of probe with respect to shuttle is v, also v again. Now what is needed to find is speed of probe relative to earth, vp with respect to e. That will be vp any third body, vp with respect to r minus v earth with respect to r, 1 minus vpr vr divided by c square. Now what we have here, we don't have vpr but we have ver, so we have to find vpr also. vpr will be vp another third body, vps minus vrs divided by 1 ps rs c square. It is given vps is v, vrs will be minus v, that will be plus v, and in the denominator one is minus and one is plus, so it will plus v square by c square. Now we will get the vpr, we will put it here, and ver from here minus v. Then we can find the vp with respect to earth, and that will be given by this, and this will be the answer. Okay, so I hope it will be okay and it will be clear to all. Okay, so we can move forward with the next question. A beam of light is propagating to a block of glass, reference refractive index n. The block is moving with constant speed v in the direction opposite to that of the beam. The speed of the light beam in a block as measured by observer in lab frame. So laboratory frame or earth frame is this. We draw this like this. Now this block is moving in this direction, and a light beam जिसका refractive index n है, block is moving with constant speed v in the direction opposite to that of the beam moving this direction, block is moving this direction. Okay, and v in the direction opposite to these speeds are with respect to laboratory frame. Okay, so given is v light beam with respect to block is c by n. How it will, we know that v1 upon v2 is inversely proportional to the refractive index of the medium, so v1 by v2 will be n2 divided by n1. So if v1 is vacuum, then speed will be c here, and here it will be 1 and it will be n, then v2 will be c by n. Okay, light with respect to block, in the second medium we have to find the v2, then v2 will be c by n. Okay, in that medium. Now speed of block with respect to earth is moving in this direction, so minus v, Okay, now what we have to find is speed of light beam in block. So with respect to earth frame, VL with respect to E, LB minus VEB divided by 1 minus LB VEB C square, all are given. LB here, BE, then it will be plus V, and we will solve this, and VL with respect to E will be this. Hope it will be clear. Not that hard, just clear your concepts. Now we're going to study about the Laurent transformation equations. Before that we studied the Galilean transformations where time was invariant, but after that we come to know that time is not invariant in the relativistic case. Okay, when the speed is very high. So Einstein and Laurent give these equations. Actually, these were given by the Laurent, and he was not that much known about these equations that they can be useful in this context. Okay, so Einstein read them and given them in these relativistic cases. So here, if we have two frames, one frame is this, second frame is this, and we will consider this rest frame, and this is moving with respect to V. Then a point P or a particle P which have coordinates x, y, z, t with respect to this rest frame, and with respect to s prime is x, y prime, this t prime in s prime. Okay, so we can directly use the formulas to calculate the coordinates in this frame. That will be x prime will be x minus vt upon root 1 minus v square c square. Now the coordinates are depending on time also. Y prime will be y, z prime will be z cube, because only in the x direction it is moving. Y and z will remain same. And yes, the most important thing here which is different from before, it is t prime. T prime will be t minus v by c square x root 1 minus v square by c square. Here this 1 minus root 1 minus square v square by c square is called a relativistic factor. Okay, we denote it by gamma t minus v by c square x. Okay, so these are Laurent transformations, and we also define from here the inverse Laurent transformation. Like we know coordinates from here, and we want to calculate in the rest frame. Then they will be x equal to x prime plus vt. Just it will move. This frame will move with respect to this in minus v direction. This will be in rest. Then just change the minus v with minus v. Then all the coordinates we will get, like t will be t prime plus v by, and here plus also. So these are called inverse Laurent transformation. Hope these are clear. Now we will consider some questions basis on that, the Laurent transformations. Two events separated by a spatial distance, this, are simultaneous in one inertial frame. Time interval between two events in a frame moving with this constant speed 0.8 c is. So it is given that two events happening are separated by a distance this. Okay, and they are happening simultaneously, means occurring at the same time. Time difference is 0 between these events, but they are distance apart. Okay, in the one inertial frame. Now there is another frame which is moving with the speed 0.8 c. Now we have to find what is the time interval. Like they were happening simultaneously in the first frame, then what will the time difference in the second frame. Okay, so it is given that t2 minus t1 is 0. This is in the first frame, difference is 0, and the difference between their space is 9 to 10 to the power 9 meter. Okay, now we have to find t2 prime minus t1 prime. Yeah, so from here t prime is t minus v by c square, so t2 prime will be t1 t2, and t1 prime will be t1 minus. So we will get this equation, t2 prime minus t1 prime, this. Now we will rearrange and get it like t1 इधर आ जाएगा, t2 minus t1 divided by 1 minus v square square v by c square x2 minus x1 minus c square, ठीक है. Now we can put substitute the values here. X2 minus x1 is 9 to 10 to the 9 meter. T2 minus t1 is 0 because they are simultaneous, and it is given. So from here, and we know the v is 0.8 c, so we'll just substitute them, and we will get answer will be minus 40 seconds. Okay, so there will be time difference between the two events in the moving frame, but in the rest frame we will see that they are occurring at the same time. So what this minus sign signify here? It is just like that t1 prime is greater than t2 prime. Okay, means t2 is less than t1. So the event, second event will happen first in the second frame. Just that. So it won't make any difference until the question will be asked about the which event is happening first. Then you just need the difference. Okay, that will be 40 seconds. Okay. Okay, let's move forward to the next question. An inertial observer sees two events even in E2 happening at the same location. So they are happening at the same location means x2 minus x1 is 0. But 6 microsecond apart in time means t2 minus t1 will be 6 microsecond. Another observer moving with constant speed v with respect to first one and sees the same event to be 9 microsecond apart. Now t2 prime minus t1 prime is 9 microsecond. Spatial distance between the events as measured by the second observer is, so x2 prime minus x1 prime is asked, and given is x2 minus x1 is 0, t2 minus this, and t2 prime minus t1 prime is this. So we need to find this x2 prime minus x1 prime. First we will use this equation t2 minus t1 prime. From here we will calculate v, because v is not given, they are just saying that it is moving with the speed v. So from here x2 minus x1 is 0, we know t2 minus t1, this I we know, and c we know. We will get v equal to root 5 by 3 c, and we will just substitute it here and we will find the x2 prime minus x1 prime. We know this value, it is 0, t2 minus t1 we know, and from here we will substitute value of v and we will get the answer minus 2000 meter, and minus sign just signify that x1 prime is greater than x2 prime. Okay, now next question. Two events, one on earth and other on sun. These all questions are asked in the previous NET exam and many GATE and JRF exams. So they are very important to understand the blueprint, how the questions are coming. Two events, one on earth and other on sun, occur simultaneously in the earth's frame. Okay, in the earth frame, though event they are occurring at the same time, the earth and the sun. Time distance between two events as seen by an observer in a space moving with velocity 0.5 c. Now a rocket or any observer is moving, and it sees that there is a difference between the time, the two between the two events. Okay, and that will be delta t. Okay, and the spaceship is moving with 0.5 c. This can be seen like that. There is earth, there is sun, spaceship is moving in this direction with v. Okay, and their event is happening simultaneously with respect to this earth frame, but with respect to this there is difference between them, there is delta t. We see the speed of light, given that light travels from the sun to the earth in 8.3 minutes in the earth frame. Earth frame, there is 8.3 minutes it will take to for the light to come from here to here. Find the value of delta t in minutes. Take the earth's frame to be inertial and neglect the relative motion between earth and sun. So if 8.3 minutes is given, then the x2 minus x1, okay, this distance can be measured, which will be 8.3 into speed of light c, that will be this distance with respect to this, and the t2 minus t1 is 0, time difference is 0. We have to find the t2 prime minus t1 prime. So this thing is equal to this, and we know that t2 minus t1 is 0, and x2 minus x1 is 8.3 c, and gamma we know root 1 minus v square by c square, 1 upon root 1 minus v square by c square, and also what we know here is that space is moving with 0.5 c. We will put 0.5 c here in the place of v, then we'll calculate and we will find that time will be 4.77 minute. Okay, so the space will observe that there is time difference which is minus 4.77. If 2D is event happening here and t1 is happening here, then from here we see that t1 is greater than t2. Okay, so t2 event will happen first, the event at the sun will be happen first according to this specific. This negative sign solves that. Now come to the next question. From this question we will move towards the length contraction topic, not exactly from this question, from the next one. So a rod PQ of proper length L, this object's length is L, the proper length, lies along the x-axis and moves toward the plus x direction with speed v equal to 3c by 5 with respect to ground as shown. An observer on the ground measures the position of P and Q in ground frame and finds the difference between them to be 9L by 10. We have to find the TQ minus TP. So here, first of all, that what is true length? So if we have to find the true length of any objects, then who can measure the true length? So only the person. So only the person who is on the object, who is on the object. So only that person can measure the true length of that object. Means if it is moving and one observer is here, then this is in rest with respect to this, so he will measure the true length of this object. Any other observer who is not on that object will measure a different length. Okay, so what is length contraction? The object here is not measuring the two P and Q at the same time. If it is, it will measure the two coordinates at the same time. Then the length come will be according to the length contraction rule. But here it is measuring at a different time, TP and TQ. So that length contraction won't come in the picture. So here we will just use the simple formulas we have already discussed, which will be like it is moving with V. So what we need to measure is TQ minus TP. Okay. So an observer on the ground measures the position of P and Q at different time in the ground frame. Okay. So what we know that actual length is L, and actual length will be in this frame. Okay, x2 prime minus x1 prime is given as L, and we have to find what the difference in time, and the length in the rest frame, what is it? It is 9L by 10. It is given here. So x2 minus x1 is 9L by 10, x2 prime minus x1 prime is L, and what else we need here? And we need to find the TQ minus TP. Okay, so from this equation we know x2 minus x1 prime, this is L, this is given 3L by whatever it was given, and we have to find this time difference in the rest frame. Okay, so we will just substitute the values. Here we'll put L and 3L by 9L by 10. Okay, and the speed we equal to 3c by 5, 3c by 5 here, 3c by 5 here, and assume it is the variable we have to find. Then substitute the values and you will get the answer. That will be maybe L by 6c something answer. Okay, so solve it accordingly, you will get the answer. Now let's discuss what is length contraction. So we said that the actual length will be measured when you measure the both end at the same time. Okay, at the same time. So if we measure the points at the same time, just consider this is an road or anything it can be, it is moving in this direction with respect to V. So an observer who is sitting on the road will measure the actual length, which will be L0, and there is this rest frame according to which it is moving. So what will be the length measured by this when they measured the length at the same time? So that length will be called length contracted length. So it is measuring at the same time, so T2 minus T1 will be 0. T2 minus T1 will be 0 because at the same time it is measuring, and x2 prime minus x1 prime is L0, x2 minus x1 is L. So we will substitute them here. This is 0, it will make whole part 0. This is L0, this is L, and L will be L0 multiply this factor. So L will be L0 root 1 minus V square by C square. So from this factor we see that L will be less than L0 because this is less than 1. So the observed length from the observer in the rest frame will measure a contracted length which will be less than L naught. Okay, so at that will be decreased by this factor. So this is called length contraction. Okay, and that's just not that the object is moving always. It can be in rest and the observer can be moving. So let's see that a rod is put on the earth and some spaceship is moving, and this is your observer here. He's measuring the length. So now actual length will be measured by the person who is on earth. That will be L naught. Okay, and the measured length from this spaceship will be L, the contracted or the apparent length. That will be L equal to L naught root 1 minus v square by c square. That will be same, and this observer will measure less length as compared to L naught. That will be called contracted length. Okay, so I hope it will be clear to you that what is length contraction. We can see the definition also. A body moving with velocity v relative to an observer. Okay, a body moving with velocity v relative to an observer appears to the observer to be contracted in length in the direction of the motion by a factor root minus v square by c square, whereas its dimension perpendicular to the direction of the motion are unaffected. The dimensions which are the y and z will not be affected. Only in those dimensions will be affected which is in the direction of the movement of the that particle or that spaceship, or it can be anything which is moving. Okay, so I hope it is clear to you. If you have any doubts, then you can put them on the in the comment section. I will try to clear them. And okay, thank you. That's all for today. We will continue from here in the next lecture. Thank you.